All right, you ready? This might be a long one. Oh boy. Okay, 2, 1, let's go. So this video is on prisms, pyramids, talking about surface area and volume. So trying to break it down for you. So I'm going to go through kind of numerous shapes so that you can see where surface area and volume come from. Now, I highly recommend, please watch the composite shapes, so calculating the perimeters and areas video before you watch this. So I'm going to put a link up above. The reason is because you do need to understand the composite shapes, because volumes, when you're taking prisms and pyramids, they're made up of multiple sides. We're going to be breaking down those sides. So here is a cube, all right, and the cube, so let's assume that, you know, the base basically, so every side is 5 centimeters. So that's what we would have. So you kind of have, so this is 5 centimeters, and then of course the height is 5 centimeters. So if you would take this, the volume here that we would have of a cube, so whenever students do this, they do know that, okay, so this is going to be, you know, base times height times width. Okay, or basically the multiplication of the 3 sides. Now, those 3 sides in a cube are identical, right? So this is kind of side 1, so I'm going to put S for side. So S times S times S. So this would have been S cubed. Now, that cubed is where our volume comes in. So for this example, all you would have had is, you know, 5 centimeters, and you would have cubed it. So this is cubed. So it's 5 times 5 is 25. So this would have been 125. And then we have to cube the unit. So this is centimeters cubed, because we have centimeter times centimeter times centimeter. So that seems to make sense when there are cubes. And so students are okay with that. Now for the surface area, you know, so you will notice, so what I have done is I have basically taken, so let's say, you know, I've taken this bottom piece, and let's say, so this is that bottom piece right here. And now, because all the sides are the same, I can kind of unfold this cube, you know, if you were trying to build it up. So I'm going to cheat a little bit here. I'm going to duplicate here. So let's say one side falls, all right? So you have one side. And what's going to happen is, you know, so I'm just making, so this is the other sides. So I'm just breaking this cube down, all right? Because how many of these are we going to have? So notice that there are 6, right? There is the base, the bottom, there's the top, and then there's the 4 sides that we have. So what I've done is here, these are your 4 sides. And then of course we still have the top piece, right? So we're missing the top piece. I can duplicate it and let's say put that top piece here. And I'm even going to change. Okay, so here, let's say this is the, let's do this. This is the top piece. So this one is the top piece. So that's the top. And this one right here that we had. So I'm trying to change this up here. Okay, so that's, let me put this is the bottom piece, all right, there, all right, and then those are your sides. So as you can see, I mean, you can certainly calculate what the area is of each side. You know, for this cube, I mean, we have 6 sides, they're all the same. So what we would say is that the surface area, so the surface, meaning the actual surface of each of those sides and tops and bottoms. So we're just interested in the area of those surfaces. So that would have been, well, I have 6 of these sides. And in this case, because they're all 5 centimeters, so basically it would have been just side multiplied by side, right? Because it's a cube. And that's 6 times. And then this would have been 5 centimeters times 5 centimeters. Okay, so that's just one of these. So each one is going to be 25 centimeters squared. So 25 centimeters squared. And now we can take 6, so we have 6 of them, so that's going to be 150 centimeters squared altogether. So we have the entire surface of this particular cube. So we should be able to do this with basically every single kind of prism. So this is a prism. It's a prism, but I mean it's a cube in particular because all the sides are the same. Now, what if the sides were not the same, right? Like what would have happened then if the sides are not the same? Well, there isn't any difference with that. So for instance, if I would take now and change the sides, so let's say that I had, so I have, again, I'm going to give this a shot. Let me draw this out here. I'm going to bring this down a little bit. Okay, I'm going to duplicate it. I'm going to, boy, I don't know if this is going to work. All right, let's say if we had something like that. Okay, so now I'm going to connect these back. Oh my goodness. Okay, I hope that it looks semi-decent. Okay, so we have, so this is a prism, right? It's kind of like, all right, we have a square base and then we just made it longer. So here we have some base within here. Maybe I should do this. All right, so here is our base right there. Okay, so let's see if that works. All right, that's our base that we have at the bottom there. Okay, now with that base, and let's say that this is still, your 5 centimeters by 5 centimeters, but now I've made it longer. So I don't know, let's make the height, I don't know, let's say 12 centimeters or something like that. Okay. Now, is this going to be any different than the square? No, it should not be any different to you, right? So what you have is, in terms of calculating the volume, so now the sides are not all the same, but we do have a base. So what I'm going to start doing is, okay, so in here, when we had our base, so that base was just a square, right? So here again, so I have a base. I'm going to call this, what I shaded in here, I'm going to call this the base. All right, so that's our base. So now if I know my base, then the volume is going to be just the base times the height, okay, that I have within there. So this is going to be the base multiplied by the actual height, okay, so that I have. And now my height here, okay, is this distance, okay, so how high this prism actually is. So that's my height h, and then the base right there is just basically your width, okay, that you have, so, and the depth of it. So the width and the depth of that particular base. Now, does the base have to be a square? The answer is no, it doesn't have to be a square. It can be anything you like, in fact. All right, so it can be a rectangle, right? So they don't have to be 5 centimeters by 5 centimeters. It can be 5 centimeters by 8 centimeters. So it can be a rectangle. But the base will still be the base. You would have always the width times the depth of that base, and that would give you the volume. So, sometimes, you just see this as base times height, and that's the actual volume, all right, of any prism. So any prism is just base times the height. Now, these prisms, they can, you can put them on their side, you can do whatever you want. You can rotate them around, flip them upside down, but you should always have some kind of a base and then having the height, all right? And for the surface area, in this case, because you have a base, now the top of it, so this piece right here, so this right here is also, so this is the top piece. So those two pieces are identical. So the bottom piece and the top piece are identical. So we have two of those. So when you're calculating, for example, the surface area, again, these are just composite shapes, but these are, in this case, there's two squares, one square at the bottom, one square on top, and then we have 4 sides. All right, so the surface area right here that you have, this is going to be your top plus your bottom piece, so plus your base, so your bottom piece is your base, and then plus all the sides that you would have. That would have been your surface area. So now the top and the bottom in this example, they're the same, right? The area is 5 times 5, which is 25. So this, for example, so this is 25 centimeters squared, but then so is this. This is also 25 centimeters squared. And now each side that we have is basically a rectangle, right? So if I would take one of these sides, so if I would take this, okay, and then what you would have is you basically would have just one rectangle. Okay, I don't know if it's proportional or not, but that rectangle, so notice it has 5 centimeters, and then it has the height, which is 12 centimeters. So you can certainly calculate, so 5 times 12, this is 60 centimeters squared as your area, okay, for this particular side. And how many of them do you have? You have 4 of them. All right, so you have 4 of those sides. So here, our surface area in total would have been, so 2 times 25 centimeters. That's because we have the top and the bottom, so those are the same, plus 4 of our sides, and that would have been this. And of course, you can compute what that is, and someone can put a comment below, okay, to calculate it for us. But the idea is, you want to be able to calculate these surfaces, and then you know that the volume is always your base times whatever, how high it is. All right, so that's what you would have. Now, so the interesting thing is, like, if I would take this thing, you can create a triangular prism. So the base doesn't have to be, as I said, it doesn't have to be a square. It does not have to be a rectangle. It can be, for instance, just a triangle. So what if you had something like this? Boy, I'm really pushing my drawing skills here, but I'm gonna give it a shot. So let's say, so I have this, and I'm doing a triangle in here. So this would have been, okay, so instead of having, instead of going and doing a rectangle, right, again as my base and then moving it up, what I'm going to do is instead is, okay, let me create a triangle in here. And now, so for this triangle, let me erase this junk here. So for this triangle right here, okay, let me duplicate, and I'm going to, let's make it grow, right? I don't know if, okay, so it seems, there we go. Okay, so now, so here's your height. Oh man. Well, anyway, so I'm giving it a shot. So you have, so something, I guess, like this. So this is called a triangular prism. Triangular prism. So that's what you have in here. Now, for the triangular prism, you still have a base, right? So this is your base. Okay, so this is your base that you have. So that's your base. Now, of course, my base, and so the area for the base is equal to 1/2, and it's the area of the triangle, right? So however you write it. Now, for triangles, we also say, base times height, but of course we can't utilize base. Here I mean the base, which is the flat surface. Okay, so what I'm going to do instead here is, so our base is just, area of the triangle. Area of the triangle. So that's what you have. And you have 2 of them. You have the bottom one, and then you have the top one. Okay, so that's what you have there. And then, you will have a height here. So this is a height. So this is going up. So this is going to be, your height to get it. So it's exactly the same as this, except our base has now changed. It kind of looks like this, right? And you know, we want to be able to have the base as our triangle, and then we just extend it up. So this is a triangular prism. And the volume of this triangular prism is still the same. So the volume is still your base. So in this case, it's the area of the triangle multiplied by the height of that. Okay? So that's what you have there, so you can find out what the volume is. Now your surface area, so the surfaces, if you take each surface, notice unlike this prism, this rectangular or cubic prism that we have, or square prism, sorry, here we had 4 sides. Well, here we don't have 4 sides, we have 3 sides. And you know, you would have to calculate each side. So you'd have to calculate the surface of each side. So for this one, you know, your surface area is equal to, okay, the area of the base, okay, and this is plus your top, of course, so because we have the top right here, so those ones are going to be the same. So we have plus the top, I'm going to put top there, and then we can't forget, okay, plus, you know, side 1, so this is going to be side 1, plus side 2, plus side 3. So this is like composite shapes, but you have to be able to spot them. Now, depending on the triangle, you know, if all the sides are the same in the triangle, then not a big deal. Then these sides are equal. But if the sides are not the same, and what I mean by that is, so here, let's say, you know, this is side number 1 of the triangle, side number 2, and side number 3. Right, so you have, you know, this is kind of like our triangle. I'm going to try to draw this here. All right, it kind of worked. It's not perfect, but okay, so this is, you know, side 1, side 2, and side 3. So your sides are going to depend if they're the same. So if side 1 equals to side 2 equals to side 3, so we have basically a congruent triangle. Everything is the same. So in that case, so though all of those things are the same, then the sides, so these sides that you have of this triangular prism are going to have the same area. But if the sides are different, let's say if side 1 is equal to 5 centimeters, side 2 is equal to 8 centimeters, side 3 is whatever, something else, then you, in those cases, you have to be careful, okay, how you're going to be calculating your sides. Most of the time in school, they make those sides the same, or they will actually make these prisms, you know, be right triangles. So they kind of will make them right triangles to make your life easier, because then you can find, remember, the hypotenuse, right, from the Pythagorean theorem when you have right triangles. So you can kind of find all the sides, and then the rest of the work is easier, okay? And I'll try to put a link to the Pythagorean theorem, the hypotenuse, up above if you've missed that one in this particular chapter. All right, so those are prisms that we have. And yes, so, you know, this is a little bit heavy, okay, that you can try it, okay, for yourself, because I wanted to be able to explain these, okay, through some kind of visual examples. The other concept is pyramids. So for pyramids, they kind of tie into exactly the same thing. Now, maybe before I jump into pyramids, what I want to show you is, this is what throws a lot of students off. Okay, so I'm going to draw a triangle here. Okay, I'm going to duplicate this triangle. What I'm going to do is I'm going to draw a prism. All right? Okay, so, hold on a second, let me draw it. Let me draw it like this, maybe. Okay, so this is what I mean. So I'm going to have this, all right, that, okay, and this. This is still a triangular prism. It has just fallen over. So notice in here, what we've done is we've taken this and we've made it fall over. So please don't get caught with these when you're calculating volumes. because here people think, you know, because it has fallen over, they all of a sudden think that this is now your new height. This is not your height. Your height is still here, okay, although it seems now like it's your length. This is your height. The reason for that is because this is just fallen over. So bring it back up. You have to kind of visualize it and twist it back up so your base is still the triangle. All right? Because here, if you're looking at this, you might think, well, this is my base, right? So this is my base right here. Okay, so that's my base, and my base is rectangular. So I'm going to have the base rectangular times the height, which would be incorrect, because what you would be doing is you would be calculating the volume of a rectangular prism. So whatever the base is, that's what the prism is. So in this case, you have to kind of flip it back over and make it a triangle again as your base, so that you can stand it up and then calculate the actual volume correctly. All right, which would have been the base, which is your triangle. So area of the triangle multiplied by the height, or in this case, the length. So be careful with that. Okay, so watch how they, you know, position these things in. Coming back to pyramids. So for pyramids, let me maybe do this. When you have a pyramid, oh my goodness, I don't know how I'm going to draw this out. Okay, so if we have a pyramid, let me see how, like, okay, so, well, you probably know kind of how a pyramid looks like. I'm going to just sketch it out, honestly. I don't know how good this is going to come out. Well, not terrible, I guess. Okay, so these are our vertices there. Okay, so this is my pyramid. Okay, so notice that in a pyramid, this is not a prism. All right, this is not a prism because the base doesn't extend through the whole, okay, height. Okay, we actually have a pyramid in here. Okay, and for this pyramid, you know, if you wanted to calculate the surface area, so the surface area for this prism, okay, so it wouldn't be that terrible because the surface area would have been equal to, so here our base, so now our base is, again, so it's you know, it's the base right there. So that's our base. But now we have plus those triangles, which are our sides, right? So it's our sides that we have as a triangle. And of course, this will depend on the base. If the base is a square, right? So if the base is a square all the way around, and this is kind of a proper, okay, pyramid, okay, where all the sides are the same, then that's not bad. Okay, so for example, so let me go back here. So 5 centimeters, you know, 5 centimeters. So all the sides are 5 centimeters, so it's a square. And then let's assume that the sides are the same. So meaning that, you know, these heights that I have, so these distances right here, okay, so these distances, so these ones are all the same. And I'm going to call this, you know, the slant of it, let's call it S, okay? And whatever that might be. So in this case, you know, let's say the slant was, for instance, let's say 7 centimeters, all right, for all of them, okay, that we would have. So if that's the case, okay, then, you know, the surface area that you have, the surface area itself is basically the base plus, you know, side 1 plus side 2 plus side 3 plus side 4. If, like in this case, the side, the slant, all right, so the slant itself is the same for everything, then, okay, those sides are going to have exactly the same surface area for a pyramid. So that should, I hope, make sense to you. You can kind of visualize those, right, if those sides are the same. Now, I have to be careful when I say, you know, this particular slant here, and what I mean by this. Okay, so, you know, let's, you know, we can assume just, Okay, let me do this. You know, the slant would have been kind of, you know, this is from the midpoint. You know, this is what I mean by the slant. The slant is, you know, from the base to the peak, all right, as you're going through, kind of from the midpoint as we have it, right? So that's the slant that you have on top. So if I would take this triangle, okay, so now you would have 4 triangles, right? So you have all of these 4 triangles because there's 4 of them. So let me duplicate this. So you have 1, 2, okay, let's duplicate it, 3, all right, and we have 4 of these. So what I'm referring to is this. Okay, so this is from the midpoint. Okay, all right. So that's what we're referring to as the slant. So all of these would have been the same. All right, and so on. Okay, so that, let's say that was the 7 centimeters. Okay, so it wasn't referring. I mean, you know, you can find out what these things are as well. All right, but I'm referring to just the slant, okay, that we have there. So now with this, that is the surface area. So the surface area is just the base and then the areas of your triangles. And then you can find out what the areas of the triangles are, okay, because, you know, if let's say, so in our example, if this was 5 centimeters from here to here, and then the slant is 7 centimeters, then you know that it's 1/2, right? So 5 centimeters times 7 centimeters, and you know your actual area of each of those triangles. If the slants are different or something like that happens, okay, if it's a weird pyramid, okay, it's not a proportional pyramid, let's assume that it is maybe proportional like it is here, so all of them are kind of the same, so this is what you would get. All right, and this would have been, so 5, so this is 1/2, this is 35, and this would have been 17.5 centimeters squared for your area of each. So my base here is 5 times 5, which is 25 centimeters. So that's my base, so 25 centimeters squared plus 4 times 17.5 centimeters squared. And you can add that up and you have your surface area of that pyramid. Now, within these pyramids, so what can happen is when you have a pyramid like this, then how do we get the volume? Because notice the volume here in these prisms, we just took the base, multiplied it by the height, and that was relatively simple. Here, okay, we can't really do that because our base is square or, you know, whatever it may be. Okay, so if you have that base, then now our height, okay, that we have is, well, we have a kind of a pyramid going up. So we have all these triangles on the sides. So it turns out that our volume, okay, so our volume is equal to, so we still take the base, all right, but now we do need the height of the pyramid. Okay, now what is the height of the pyramid? The height of the pyramid we can find out. And the reason is because we know the slant, okay, of those pyramids. So if you know the slant of that pyramid, you can actually find the height again using the Pythagorean theorem. So here, so this is the base times your height. And now it is multiplied by 1/3. And for that, okay, so 1/3, where does this 1/3 come from? So one can actually show this, and if time allows me, I'm going to do a video on that, and I'll put a link up above there. So if you're going to see a link there, that means you can check to see where this 1/3 has come from for this pyramid. All right, if the link is not there, the video hasn't been made yet. So here, that is the volume of your pyramid that you would have. And now your height, as I said, you can find your height. And that the reason for that is, so here, this is how you find it. Okay, so that is your S, that's your slant, okay, of your pyramid. So that's what the slant is. Now, of course, what we had, Okay, so we had, okay, this was our base. You know, in that case, this is the base itself. That's the side of the base. For us, it was 5 centimeters. And what we're trying to look for is we're trying to find this height, right? So how high that pyramid actually is. So notice what you know is, you know the hypotenuse, okay, from our base, all right? So what we have in there, that's 5 centimeters. So this is going to be 2.5 centimeters because it's half of that. So you know one of the sides, and now you can find this height because this is a right angle triangle. So you're using the Pythagorean theorem to find your height. So if someone gives you the slant, you can find now the height, and then you can find the actual volume. All right. And again, that 1/3, I'll try to post that video and the link in there as time allows me. Okay, so that is a heavy class. You can go through this and hopefully rewatch and try to understand the surface areas and then the volumes, and more examples will come in the future. All right, thanks for watching. See you in a future video. Bye, everybody.